To expand knowledge of refrigeration systems, consider these resources. Several books provide a strong foundation. Firstly, Refrigeration and Air Conditioning Technology, 8th edition by Edward E. William and Richard S. Cavanaugh is a comprehensive text. Secondly, Modern Refrigeration and Air Conditioning, 10th edition by Andrew D. Althouse College, Turnquist and Alfred F. Braxino is another valuable resource. Thirdly, Principles of Refrigeration, 7th edition by Dossat Roy J. offers detailed insights. For online resources, begin with the American Society of Heating, Refrigerating and Air Conditioning Engineers, or ASHRI website. Their website provides a wealth of information and resources. The Council of Air Conditioning and Refrigeration Educators, or CAR, website is another helpful platform. Explore Emerson Climate Technologies Technical Library for specific technical documents. The Refrigeration School website offers training and educational materials. Consider these online courses and resources. Firstly, the HVAC Technician Training course on edX. Secondly, the Refrigeration and Air Conditioning System Specialization on Coursera. Thirdly, Refrigeration and Air Conditioning courses on Allison. These resources offer structured learning opportunities. For supermarket refrigeration, consult specific resources. Firstly, Design, Construction, and Maintenance of Supermarket Refrigeration Systems, ASHRI Handbook, Chapter 47. Secondly, Supermarket Refrigeration, a Guide for Managers and Engineers by Frank E. Kramer. Thirdly, Advanced Supermarket Refrigeration Systems by John C. Beckett. These materials cover the unique aspects of supermarket refrigeration. Refrigeration cycles are fundamental to understanding how these systems work. The basic refrigeration cycle consists of four main components. Firstly, the compressor. Secondly, the condenser. Thirdly, the expansion valve. And fourthly, the evaporator. The compressor increases the pressure and temperature of the refrigerant vapor. This high-pressure, high-temperature vapor then enters the condenser. In the condenser, the refrigerant rejects heat to the surrounding environment, causing it to condense into a high-pressure liquid. This liquid refrigerant then flows through the expansion valve, which reduces its pressure and temperature. This low-pressure, low-temperature refrigerant then enters the evaporator. In the evaporator, the refrigerant absorbs heat from the surrounding environment, causing it to evaporate into a low-pressure vapor. This vapor then returns to the compressor, completing the cycle. Different refrigerants have different properties, influencing system performance and environmental impact. Common refrigerants include R-134, R-410A, and ammonia. Natural refrigerants like carbon dioxide and propane are also gaining popularity due to their low global warming potential. System design considerations are crucial for efficient operation. This includes selecting the right components, sizing them appropriately, and ensuring proper insulation. Supermarket refrigeration systems often use multiplex systems, where multiple display cases are connected to a central refrigeration unit. These systems require careful design and control to maintain consistent temperatures and minimize energy consumption. Control systems play a vital role in regulating the refrigeration cycle and maintaining desired temperatures. Electronic controllers use sensors to monitor temperature and pressure and adjust the operation of the compressor, expansion valve, and other components. Advanced control strategies, such as floating head pressure control and electronic expansion valves, can further improve energy efficiency. Maintenance is essential for ensuring the reliable and efficient operation of refrigeration systems. Regular maintenance tasks include cleaning coils, checking refrigerant levels, and inspecting for leaks. Proper maintenance can prevent costly breakdowns and extend the life of the equipment. Troubleshooting refrigeration systems requires a systematic approach. This includes identifying the symptoms, gathering information, and using diagnostic tools to pinpoint the problem. Common problems include refrigerant leaks, compressor failures, and control system malfunctions. Understanding electrical wiring diagrams is crucial for servicing refrigeration equipment. These diagrams show the electrical connections between the various components of the system. Being able to read and interpret these diagrams is essential for diagnosing and repairing electrical problems. Safety precautions must always be followed when working on refrigeration systems. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses. It is also important to be aware of the potential hazards associated with refrigerants, such as flammability and toxicity. Understanding the different types of compressors used in refrigeration systems is important. Reciprocating compressors use pistons to compress the refrigerant. Scroll compressors use two spiral-shaped scrolls to compress the refrigerant. Screw compressors use rotating screws to compress the refrigerant. Each type of compressor has its own advantages and disadvantages in terms of efficiency, reliability, and cost. Evaporators are designed to efficiently transfer heat from the refrigerated space to the refrigerant. Common types of evaporators include fin tube evaporators and plate evaporators. The design of the evaporator affects its heat transfer capacity and its ability to defrost. Condensers are designed to efficiently reject heat from the refrigerant to the surrounding environment. Common types of condensers include air-cooled condensers and water-cooled condensers. The design of the condenser affects its heat rejection capacity and its energy consumption. Expansion valves control the flow of refrigerant into the evaporator. Common types of expansion valves include thermostatic expansion valves and electronic expansion valves. The expansion valve must be properly sized and adjusted to maintain optimal system performance. Defrosting is necessary to remove frost that accumulates on the evaporator coil. Frost reduces the heat transfer capacity of the evaporator and can lead to reduced system performance. Common defrost methods include hot gas defrost, electric defrost, and air defrost. Superheat and subcooling are important parameters to monitor in a refrigeration system. Superheat is the temperature of the refrigerant vapor above its saturation temperature at the evaporator outlet. Subcooling is the temperature of the refrigerant liquid below its saturation temperature at the condenser outlet. Monitoring superheat and subcooling can help diagnose problems with the system. Refrigerant charging is the process of adding refrigerant to the system. It is important to charge the system with the correct amount of refrigerant to ensure optimal performance. Overcharging or undercharging the system can lead to problems. Refrigerant recovery is the process of removing refrigerant from the system. It is important to recover refrigerant properly to prevent it from being released into the atmosphere. Refrigerant recovery equipment must be used to ensure that the refrigerant is not contaminated. Oil management is important in refrigeration systems. Oil is used to lubricate the compressor and must be properly managed to prevent it from causing problems. Oil separators are used to remove oil from the refrigerant stream. Leak detection is important to identify and repair refrigerant leaks. Leaks can reduce system performance and release refrigerant into the atmosphere. Common leak detection methods include using electronic leak detectors and soap bubbles. Vibration analysis can be used to detect problems with a compressor and other rotating equipment. Vibration analysis involves measuring the vibrations of the equipment and analyzing the data to identify potential problems. Energy efficiency is an important consideration in refrigeration system design and operation. There are many ways to improve the energy efficiency of refrigeration systems, such as using high-efficiency components, optimizing control strategies, and implementing proper maintenance practices. Building automation systems can be used to monitor and control refrigeration systems. Building automation systems can provide valuable data on system performance and can be used to optimize energy consumption. Codes and standards govern the design, installation, and operation of refrigeration systems. These codes and standards are designed to ensure the safety and performance of refrigeration systems. Examples of codes and standards include the National Electrical Code, or NEC, and ASHRAE standards. The National Electrical Code, or NEC, is a widely adopted standard for electrical safety in the United States. Several articles within the NEC address specific requirements for refrigeration and air conditioning equipment. Firstly, Article 440 covers air conditioning and refrigeration equipment. This article provides requirements for motor compressors and other components used in these systems. It addresses issues such as disconnecting means, overcurrent protection, and conductor sizing. Secondly, Article 210.8 addresses ground fault circuit interrupter, or GFCI, protection. GFCI protection is often required for receptacles located in areas where refrigeration equipment is serviced, such as near water sources. Thirdly, Article 250 covers grounding and bonding. Proper grounding and bonding are essential for electrical safety and to prevent electrical shock hazard. This article provides requirements for grounding the metal parts of refrigeration equipment. Fourthly, Article 310 provides guidelines for conductor ampacity. It helps determine the appropriate size of conductors for supplying power to refrigeration equipment, ensuring that they can safely carry the required current. NEC Table 310.15b16 is commonly used to determine the allowable ampacities of insulated conductors. This table provides ampacity values based on conductor size, insulation type, and ambient temperature. It is important to note that the NEC is updated regularly, so it's essential to consult the latest edition for the most current requirements. Local codes and regulations may also apply, so it's always best to check with local authorities to ensure compliance. When sizing conductors for refrigeration equipment, it is important to consider the nameplate information on the equipment. The nameplate provides information about the equipment's voltage, amperage, and other electrical characteristics. The minimum circuit ampacity and maximum overcurrent protection device rating are particularly important for conductor sizing and overcurrent protection. The locked rotor amps, or LRA, is the current that the motor draws when it is first started. This value is used to determine the size of the overcurrent protection device. The full load amps, or FLA, is the current that the motor draws when it is running at its rated load. This value is used to determine the size of the conductors. Understanding the different types of overload protection devices is important. Overload protection devices are designed to protect the motor from damage due to excessive current. Common types of overload protection devices include thermal overloads and electronic overloads. Ground fault protection is designed to protect people from electrical shock hazards. Ground fault protection devices, such as ground fault circuit interrupters, or GFCIs, detect ground faults and interrupt the circuit to prevent electrical shock. Surge protection is designed to protect equipment from damage due to voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. Surge protection devices, or SPDs, divert the surge current to ground, protecting the equipment. Control wiring is used to connect the various components of the refrigeration system. Control wiring must be properly sized and protected to ensure reliable operation. Wiring diagrams are essential for troubleshooting control wiring problems. Electrical safety is paramount when working on refrigeration systems. Always disconnect power before working on electrical components. Use appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards associated with electricity, such as electrical shock and arc flash. Proper lockout/tagout procedures must be followed to prevent accidental energization of equipment. This involves disconnecting the power source and placing a lock and tag on the disconnect switch to prevent it from being turned on. Regular inspections of electrical equipment are important to identify and correct potential problems. Inspections should include checking for loose connections, damaged wiring, and other signs of wear and tear. Proper documentation is essential for maintaining refrigeration systems. Documentation should include wiring diagrams, equipment specifications, maintenance records, and troubleshooting information. Staying up to date on the latest technologies and best practices is important for professionals in the refrigeration industry. This can be achieved through continuing education courses, industry conferences, and trade publications. Proper disposal of refrigerants is essential to protect the environment. Refrigerants must be recovered and recycled or destroyed in accordance with environmental regulations. Never release refrigerants into the atmosphere. Understanding the regulations governing the use of refrigerants is important. Regulations vary depending on the type of refrigerant and the application. Be sure to comply with all applicable regulations. By understanding these concepts and resources, you can expand your knowledge and skills in refrigeration systems and effectively service supermarket refrigeration equipment.